So have you ever imagined that an AI agent that not only understands what you're asking, but instantly spins up resources across the cloud for you, connects to dozens of apps, executes tasks automatically, and scales to handle millions of requests without breaking a sweat? Now that's not science fiction, of course. We are actually seeing it, and that is the reality of cloud-native AI agents. And they're quietly transforming how businesses and developers build intelligent, automated systems. So I'm going to show you exactly how cloud-native AI agents are, how they work, whether they're so important, and how they're already changing industries around the world. Now, by the end of this video, you are going to see how these agents might be the future of AI-driven automations. So welcome back to ClayDesk. My name is Syed. So if you're new here, I'm glad you joined because today I'm going to dive deep into one of the most exciting trends in artificial intelligence, which is cloud-native AI agents. Now, these aren't just chatbots, right? Or simple scripts that are run locally. They are intelligent programs designed to live and breathe in the cloud. Now, they can reason, they can learn, they can interact with APIs and perform tasks autonomously, all while leveraging massive scale and power of cloud platforms like AWS, Azure, and GCP. So think of them as highly skilled digital workers. They don't get tired. They can collaborate across dozens of systems and who can handle workloads that will overwhelm human teams. So let's start with the basics first. What exactly is a cloud-native AI agent? At its core, it's an AI-powered program built to run natively on the cloud infrastructure. So it isn't tied to one server or one machine, but instead it's designed to operate in a distributed environment, or it can take advantage of the everlasting computing power, global availability, and seamless integration with other services. So unlike traditional AI applications that often run on fixed servers, for example, in a local environment, cloud-native agents inherently are flexible and scalable. Now they can handle a certain spike in requests automatically. They can operate across multiple regions and connect directly with other cloud-native applications through APIs. Now this makes them ideal for real-world scenarios, for speed, scale, and connectivity, which are crucial. So imagine a single AI agent monitoring thousands of IoT devices around the world in real time, flagging issues, coordinating maintenance schedules, and even ordering replacement parts through an e-commerce API, all while running autonomously in the background. That's what we mean by cloud native. Now you might be asking yourself, why does this matter? Well, why not just run AI agents on regular servers or even on-premise infrastructure? Well, the answer comes down to scale and flexibility. Cloud-native design meets these agents' design that automatically scale during peak demands and scale down when they're idle, saving resources and reducing costs. They can also run closer to where your users are, reducing latency and improving response times as well. Now, the cloud also provides built-in tools for networking, storage, authentication, and monitoring, which means developers don't need to reinvent the wheel every time they deploy an AI system. And more importantly, the cloud enables integration, right? So AI agents aren't useful in isolation. They need to connect to CRMs, databases, communication platforms, and much more, like Salesforce, for example. And cloud-native agents can tap directly into these services because they share the same ecosystem, which makes automation seamless. Now, how do these agents actually function in the real world? Well, at a high level, they combine three critical layers. First, you have the reasoning engine, which is usually powered by a large language model or specialized AI model. Now, this is what allows the agent to understand complex instructions, plan multi-step actions, and even adapt its behavior over time. Second, you have the cloud infrastructure itself. Now, these agents run on platforms like AWS, Azure, or Google Cloud using services. They can use serverless functions, manage databases, and scalable storage to handle workloads dynamically. And finally, there's the third step, which is the integration layer. Now, this is what connects the agent to real-world systems, APIs, and event-driven triggers, and microservices that let it take action beyond just generating text. So let's take an example. Suppose you run an online store. A cloud-native AI agent could automatically track incoming orders, check inventory in a cloud database, trigger fulfillment workflows through a logistics API, and send confirmation emails to customers and update your accounting system, all without any manual intervention. Now, because it lives in the cloud, it can scale instantly during a holiday rush in hand and can handle thousands of orders at once and automatically scale back down afterwards. These agents are not hypothetical, by the way. They're already being used today as we speak across multiple industries. So in customer support, for example, AI integrated with cloud CRMs can handle massive ticket volumes, resolve issues, escalate when necessary, and learn from past cases to improve responses. In finance, for example, agents can monitor transactions in real time, like fraudulent behavior, for example, and even execute preventative action instantly. In healthcare, another example, cloud-native AI agents are being deployed to schedule patient appointments, analyze medical imaging, and manage complex administrative workflows securely and efficiently. Even IT operations can benefit from these. Imagine an AI agent constantly monitoring a company's cloud infrastructure. It can detect abnormal spikes in traffic, automatically provision more servers, for example, and even roll back problematic deployments, all without human intervention. This is where cloud-native AI agents truly shine because they act autonomously, but also collaborate with other tools and systems, functioning like tireless digital teammates. The advantages are absolutely clear. Cloud-native AI agents offer scalability, cost efficiency, and continuous learning capabilities altogether. Eliminate the bottlenecks of fixed infrastructure and adapt to changing workloads effortlessly. But of course, this isn't without challenges and costs. Security is a major concern. Now, when you have autonomous agents operating across cloud services, API key management, identity access controls, and audit trails becomes critical. There's also complexity as well. Now, building and deploying these agents often requires strong DevOps and cloud engineering skills. Plus, while the cloud provides an incredible flexibility, it also introduces dependence on stable connectivity and the reliability of underlying cloud platforms. So, looking ahead, we are going to see cloud-native AI agents become more autonomous and more collaborative. It won't just execute predefined tasks, they'll actually work together, forming multi-agent systems capable of coordinating complex workflows across different domains. So we'll see agents optimizing cloud resources automatically, negotiating tasks with each other, and integrating more deeply into enterprise systems. Now, with the rise of serverless AI, event-driven architectures, and real-time streaming data, these agents will start to feel less like tools and more like highly capable digital colleagues. So here's the bottom line. Cloud-native agents are not just another buzzword. They represent a fundamental shift in how we build, deploy, and interact with intelligent software. They combine the reasoning power of AI with the elasticity of the reach of the cloud, opening doors to automation and intelligence at scale we've never seen before. The question is whether it'll be adopted, is how quickly. So, let me know what you think. Comment down below and let me know what you think about this AI agents or cloud-native AI agents. And be sure to like, comment, and subscribe and hit the bell notification. My name is Syed, and I'll see you in the next video.